This is the first Quip of this channel. Today, with C++, I'm going to be teaching you how to make your PC tell you to go fuck yourself every single time you turn it on. So to start off, I'll be using Visual Studio, Microsoft Visual Studio, because I find it runs with the Windows runtime better. I will not be going into Linux stuff, at least not yet. But for this, we're going to be going to create a new project, an empty C++ project. I like using the empty project because it allows more freedom with how you want to set up your project directories. Then you're going to go to next. Name it whatever you want. So I'm going to name it the purpose of this program, and that's to tell us to go fuck ourselves. As simple as that. And I'm saving this to a testing file. You can place the solution in the same project as the directory. And honestly, I would prefer to do that so I don't have to go looking elsewhere for the file. Now we can create. And you're going to get this blank screen, this pretty bland screen. On the right hand here, you can see source files. Right click here, go to add, new item, and you can name this anything you want as long as you keep the .cpp. That tells the computer that this is a CPP file and also tells the encoder that it is a CPP file. You can name it anything. I often choose base because it's like a base point, a starting point. It makes finding the area where the code enters way easier when I'm going back to debug and I have like a million scripts. So we're going to simply start off with int main to initialize main. And then we are going to simply write std, which stands for standard, cout, which stands for console out, writing out to the console. And in parentheses, we're going to write what we want it to say. Go fuck yourself. If I could spell. All right. But that's not all. Std count actually requires a library. And to include this library, we must write #include iostream. It needs iostream to talk to the console itself. Now, with this alone, actually, for safety reasons, I'm going to include return 0. It's just a way to exit out cleanly instead of having it just figure it out itself. Now, with all of this, we could technically be done here. If I run the local Windows debugger, it'll boot up a terminal and run the script in it. See? There it is. Exactly what we wanted to say. Go fuck yourself. But it also has all this debugger mumbo jumbo. In reality, what this is telling us is that the program just exited with a code of 0, return 0. We just told it to close. This will happen instantaneously. Actually, to demonstrate, I'm going to switch this to release, as I often switch most things to release since I debug in the window debugger. And I am going to build the project. And I'm looking this way because my file explorer is all the way over here. After it has built, we can go, wrong folder. We can go to the 64, release, and it instantly closes. Why does it do that? Well, simply put, it reads this line as the beginning point. It then reads this, and as soon as it reads that, it ends the program. So this will instantaneously close the program. So we don't want it to do that. So what I'm going to do is use a trick that I often use, and that involves including the string library. The string library has a helpful variable that basically stitches together characters so you can write long sentences. And to build one of these variables, you write std string for standard library string and the variable name. I often do ANS or answer for console-related strings, or input-related strings, I should really say, because you're answering a prompt given to you by the console most of the time. And I'll be using a while loop and strings getLine function. GetLine essentially waits to read whatever's outputted into a specific area. So you will give it a area to read in. For us, it's C in, or console in, or the console space. And then you'll give it something to store that in. For us, it's answer. And then, since we don't want this constantly looping here and never breaking out, we're going to add break. And break does exactly what it says it does. It breaks. It breaks out of this while loop. So now if we run the local Windows debugger, there we go. And it doesn't instantly give us the debug stuff. And that'll happen the same way with a normal runtime, or when you normally run it. Now, if we want to get more obvious with this program, it gets a little more complicated because what I used to do in the past seems to not work anymore. As I've moved past most terminals in my normal coding day-to-day, I didn't realize this happened. So now what we're going to have to do is include the Windows runtime, the Windows library. And also, we're going to have to right-click on the project, go to Properties, Linker, System, and then go to Windows. And now, instead of initializing main, okay, never mind. My monitor just suddenly turned off. That was strange. Now we have to initialize Win API, Win main, and you can do a cool little trick because half the time I forget how to initialize this. You can peek the definition of this and just straight up steal this. But the in-opt, all of that isn't technically necessary, so you can go and clean them out. Because the program already knows that that's what it's doing. So when it goes to read the actual scripting for it, it'll already know that that's what's supposed to happen. So now that we're initializing like this, we can now get the console window. To get the console window, we need to build a handle for the console. And this essentially just grabs all of the window behavioral stuff like positioning and sizing and keeps it in one variable. And that you can mess with that as well. You can get console window. And then now with set window position, you can do whatever you want to this window. So we're going to throw in... Actually, I'm sorry. I'm misremembering. This is the exact thing I said doesn't work anymore. So I'm sorry. You don't have to do all this crazy stuff anymore. We can go back to the normal console. And we can, frankly, get rid of all of this. Switch it back to main. And we can just delete all these variables. Those are just initialization variables. It helps run stuff. Some of them actually get attributes when you load them in. But with the new way of doing it that I found, you can simulate keyboard events such as the F11 key. The F11 key, if you don't really know, full screens your whole screen or the window that you're on. So what you can do is keyboard event. And then you can get the V code. The V code is really simple. It's straight up just VKF11 and then fill the rest with zeros. And that basically just tells it, hey, I'm pressing the key down. And then we're going to want to tell it to bring the key up, since if the key stays down, it may actually make it impossible to put inputs in. We're going to tell it to grab that same key again. And then we're going to do key event F, key up, and then finish with a 0. And this will tell the key that it's back up and it's not being pressed down anymore. Now, when we run this, it'll immediately full screen and tell us to go fuck ourselves. Isn't that way more obvious? Wouldn't you freak out if your computer instantaneously black screened and told you to go fuck yourself? Now, you can get more creative than this, and you can center it, you can change the color of the text, but for this tutorial, that's where we'll leave it. So now we're going to want to build the program. So you now have a new up-to-date build. So how do I get this to start up instantly? You go to Windows R and you write shell ::startup. I'm sorry, it's single colon. It'll take you to your startup folder. Now you can see I do have something in my startup folder, and that is this menu. This is part of my startup menus. But simply, all you need to do, and let me put those side by side, is, oops, not properties, more options. All you need to do is create a shortcut and drag it in, and it will start instantly. Or not instantly, I shouldn't say instantly. It'll start with your computer. There are ways to make it start quicker, but because I don't want to get into super technical stuff and potentially damage your machine, I will not be going over that. I personally have it, but I'm not entrusting the whole world with it. So thank you again, and go fuck yourself.